welcome to this second webinar for the Sustainable Bus Tour. So good morning from myself, I'm Riccardo Schiavo
and Fabrizio Dalle Nogare.
So we are really happy to welcome you at this new event. Some of you maybe have been connected also in May when we broadcasted our first webinar for this year initiative. We were followed by over 1,000 people, and the topic was electrification on large bus fleets. Starting this year, then webinars and events are part of our editorial offer and joins a web platform which is already completed by a magazine with a couple issues per year. The last one was out just a few weeks ago. And it's a good occasion to mention that the editorial offer of our publishing house on the topics of sustainability, innovation, energy transition in transport is getting wider. Correct, Fabrizio?
You're right, Riccardo. In June, we launched a brand new website, which is called Sustainable Truck and Van, and is focused on zero-emission commercial vehicles. In addition to the daily updated website, we've got a weekly newsletter published every Wednesdays, and it's very easy and free to subscribe. You just need to go to sustainabletruckvan.com.
Okay, so back to today's webinars. As of June this year, there were around 150 hydrogen buses in Europe, but there are plans to reach over 1,200 by 2025. According to WTP, but we will see this more in the detail in a moment. In 2030, more or less 10–12% of the city bus market in Europe will be made of fuel cell buses. So which is the market potential for this technology? Are fuel cell buses going to find place more in city or intercity application? How to deal with the infrastructural aspects of this technology? Today we'll try to answer this and many more questions with the help of a whole lineup from the public transport and the industry section.
So let's now introduce all our speakers. So for the first part, the introduction, we will have Efe Uzanmaz, who is Manager Knowledge and Innovation Department at WTP, and Lionel Boyot, Project Manager at FCH-JU, Fuel Cell and Hydrogen Joint Undertaking. For the future of, about the future of hydrogen in public transport, we will talk with Bart Kruiwanger, Manager Zero Emission Programs at Transdev Netherlands, Thomas Fontaine, Managing Director at Keolis Dijon, Petra Piffer, General Manager at SASA Bolzano, and Wolfgang Reitmeier, Head of Depots, Workshops and Electric Mobility at VDV. Finally, the fuel cell bus industry chain will be in the spotlight. And we will host Radiša Nunic, Director of Public Affairs for Hydrogen at Worthington Industries, David York, Market Development Manager Europe at Ballard Power Systems, Eugen Hall, Vice President Research and Development at Siemens Commercial Vehicles, Paulo Marques, CTO at Caetano Bus, and Alexander Schabert, CCO and co-founder of ViriCity.
Wonderful. I guess it's really time to start. So Efe will outline from the perspective of WTP, of the International Association of Public Transport, which are learnings, which are outlooks and market potential regarding fuel cell buses. So please, Efe.
Thank you, Riccardo. Thank you for the nice introduction, and it's my pleasure to kickstart this interesting webinar, actually. So a warm welcome from UITP side as well to all participants and speakers. I'm Efe Uzanmaz from UITP's Bus Unit Knowledge and Innovation Department, and there we believe that it's time to accelerate the deployment of clean bus fleets in our cities. And to do so, we need commercial technologies at one side, and we need also to facilitate the best practice knowledge exchange around the key network of stakeholders. So today I would like to propose you the way forward to clean bus fleets by a quick look to Clean Bus Europe platform and JIVE and JIVE2 projects. So the CBEP, as we call it, is an initiative by the European Commission and implemented by UITP to facilitate the knowledge exchange and in clean bus deployments. And JIVE and JIVE2 are the flagship project funded by FCH-JU, really deploying fuel cell buses in European roads, therefore to pave the way the commercialization of fuel cell bus in the future. Just a word about UITP. We are the International Association of Public Transport. We are the only worldwide network to bring together all public transport stakeholders and all sustainable transport modes. We are a technology neutral association, so we support our members mainly in 3 key pillars, which are advocacy and outreach, networking and business, as well as knowledge generation through projects and working bodies. And in this case, the fuel cell buses as well. So just to remind us the general rationale behind the clean bus deployment. So we already see that the transition had already started in the past with an idea to decrease the local CO2 emissions in our cities. But today we have also a legislation push coming from the EU policy framework. It's a Clean Vehicles Directive that accelerates the deployment of clean and energy efficient city buses with mandatory procurement quotas. By saying mandatory procurement quotas, of course, the PTOs, the PTAs will be obliged to deploy a number of buses according to those categories. But at UITP, we feel that it's an opportunity rather to think our bus systems in the future and to reflect on the quota. So accordingly, from August 2021 until December 2025, the newly procured buses, the 45% of the newly procured buses should be clean, and half of it should be zero emission technologies. And this number will go up from January 2026 to December 2030 from 65% as the clean fleets, and the half of it should be zero emission, meaning 32.5. So overall, it's a good push in almost all member states in achieving the clean fleet technologies, and some lower quotas apply in the remaining member states. Just to give you an overview about the technologies available in the market with a reference to Clean Vehicles Directive, we have 5 main technologies: battery electric, plug-in hybrid, natural gas, fuel cell buses, and IMC trolley buses. But only 3 of them, battery electric, fuel cell, and IMC trolley buses, are giving us the zero emission solution. And according to UITP data, we have around 200,000 city buses in European networks, and approximately around 15,000 are replaced each year from diesel to zero emission or clean solutions. So here we see that the replacement are still from the diesel. So we see that the diesel are still our benchmark, especially when it comes to the autonomy and range, because with a standard 12-meter city bus, you can have a range up to 700 kilometers. So it sets the goal for us. And when we zoom into the different parameters of comparisons between technologies, if we look at the fuel cell, it's one of the comparable zero emission bus technology to diesel, because with a fuel cell bus, you can go up to 350 kilometers with 1 refill or more, depending on your operational condition. And it's a similar experience with diesel bus, especially when it comes to refilling, because you can refill a fuel cell bus between 5 to 10 minutes. When it comes to charging and investment, infrastructure investments, the CapEx cost initially, it's higher as the other zero emission technologies, but we have also a relatively competitive advantage in fuel cells, because with 1 hydrogen refueling structure in place, you can accommodate larger fuel cell bus fleets according to your needs. When it comes to impact on operation, of course, as other zero emission technologies, you need to rethink your bus adaptations, workshops, and as well as the training of bus drivers, like other solutions. And when it comes to impact on urban landscape, it's relatively low, as we see, because you can place the hydrogen refueling infrastructure strategically according to your city needs. So while we are talking about the technologies, I would like to present shortly the industry view on the clean bus technologies penetration. So this is a study done from UITP's industry committee back in 2017. So it clearly shows us that the industry was confident at that time that the diesel will be replaced by battery electric buses and fuel cell buses by 2030. And when we look at the figures by 2030, as Ricardo said in the beginning, we see around 12% market share for fuel cell buses, whereas this is around 45% for battery electric bus and 18% for CNG biogas, and around 16% for plug-in hybrid. So this tell us a flavor about the key trends today and the future. And we see that battery electric buses are currently taking the lead in this transition. We know that plug-in hybrid and CNG are stabilized, as you see in the figures, by the time. So we see that as a transition technologies. And also we know that CNGs and biogas has different market penetration across different member states. But all in all, the most important that reflects in today's webinar is fuel cell hydrogen bus technology is consolidated as a viable zero emission solution. While this transition happening, we have the Clean Bus Europe platform. So it brings the network of stakeholders together to facilitate the knowledge exchange around the zero emission bus technologies and other clean solutions. So on one side, we have PTOs, PTAs, city authorities, industries, and at the other side, funding and financing institutions and other associations that are members of the platform. We have a twinning approach. Basically, we have host experience cities in some technologies and learning cities in some other technologies, and we match those cities to learn from each other. And for example, we have Amsterdam and Eindhoven as host cities represented by Transdev, a colleague today, and Dijon as a target city. And for example, Cayetano Bus is an industry member. So we have a dedicated work plan to achieve this facilitation. We have knowledge and expertise exchange, technical support around key issues like tendering and operations, also matching supply and demand, meaning bringing PTOs and industries and funding institutions together. So if you are interested to become a partner or become a member of the Clean Bus Europe platform, we invite you to check the website. And of course, the technologies are covered, the link to all clean vehicles directive, and most importantly, we also cover fuel cells and hydrogen. Just to show you the key solid toolkit information that you can find in the Clean Bus Europe platform, we developed with sustainable bus market monitoring so that you can see the European bus orders, tenders, and services in place today. And we have a library, solid knowledge material around the clean bus deployment. So when we talk about this transitioning happening, also the consolidation of fuel cell buses, we rely very much on JIVE and JIVE2 projects in Europe as flagship projects funded by FCHJU, because in the projects, as UITP is also a member of the consortia, we deploy 310 fuel cell buses across 18 cities and regions in Europe. So the idea is really to validate the large-scale fleets in operations, because in the last decade, with fuel cell buses, we started around 3 to 5 bus demonstrations, and now the numbers are growing towards 50 buses with JIVE projects. The overall goal is to decrease the standard fuel cell bus around 650K in JIVE and 625K in JIVE2. To achieve this bus prices, we also exercise joint procurement methods, and I think it will be covered by Lionel extensively, to access the economies of scale. And in parallel, the projects also deploy the hydrogen refueling stations in those cities to really create the pipeline for the future of fuel cell deployments. Just to give you the current status from the projects, to date, we have 17 cities and regions placed bus orders from 6 different suppliers. So this totalizes the bus orders to 274 buses, and some of the buses are operational and creating performance data. So there's a long list of cities. You will hear it shortly from Bolzano. I would like to point out mainly the key idea of bus deployment. So you will see the bus numbers ranging from 5 to 50. So this gives you the idea about the scale in JIVE projects. And critically, the cities are deploying around 10-20 buses, and we know Bolzano is 12. In terms of bus suppliers, now we see that the market is stimulated, and we have more diversified offers by 6 suppliers. And in terms of type of the hydrogen, we see that most of the cities get their hydrogen through green and then electrolysis method. So what's next from JIVE point of view, also about the fuel cell bus agenda in Europe? Definitely we need more JIVE demonstration data coming up, also the comparisons and the idea around TCO, the performance analysis of the buses. We also need the supply side diversification if we want to increase the share of fuel cell buses, as Ricardo was saying, maybe to articulated buses or intercity coaches, and also to to study the scaled multi-use infrastructure effect. This will also help us to achieve a scaled system, meaning that fleets with more than 100 buses also to access cheaper hydrogen solution. And therefore, an overall idea would be by 2030 is to assess and study the integrated hydrogen energy systems, meaning that more cities and regions are creating the framework for hydrogen ecosystems and economies. I would like to end up with the key resource at UITP, lessons learned by the JIVE and JIVE2 projects. We put together a knowledge brief in July 2020, where you will find a key storyline, do's and don'ts of deploying fuel cell buses gained through JIVE cities. So we touched upon the project conceptualization, meaning the setting up of the project, to financing and planning and procurement. So also this brief is available in 8 European languages and can be downloaded by UITP website or the fuelcellbuses.eu, which is the official website of the JIVE and JIVE2 projects. So all in all, this was my short introduction. I think that the fuel cell bus technology is consolidating and also technologically proven with the JIVE projects and other demonstration projects. For future scale up, we need best practice knowledge exchange, definitely. And for this, I think we are in the right hands today with a panel of speakers specialized in the market and also operating fuel cell buses. So big thanks from UITP side.
Great, thank you also for the sustainable bus side. Thank you also for mentioning the good cooperation we have on the Clean Bus Europe platform. We will have the occasion to go also deeper on the JIVE1 and JIVE2 projects with FCH JU in a moment. Now we have to change a little bit our agenda. Before letting the screen to Leonel Boileau, we have to introduce Miss Petra Piffer from the Italian municipal company SASA Bolzano. She's connected from Rome from a meeting. She will have to leave the webinar before 3:30, so ladies first, okay? 10 years ago, SASA started with the first pilots. Now, the latest news is the realization of a hydrogen refilling station inside the depot. So why did you choose to focus on fuel cell bus technology, and which are the company's strategies in this regard? Please. Ms. Piffer, apparently we don't hear you.
So now it should work.
Okay.
Thank you very much for giving me the opportunity to share our experience. Yes, our vision is zero emission public transport, and this is our vision now for a long time. We were one of the first in early 2014. We'd run the CHIC project with 5 hydrogen buses. They are still on service, and I must say we have an extraordinary good experience with those buses. This confirms what also Ify said, that the fuel cell technology is proven to be a valid technology, and for that that was one reason because we wanted to go ahead with that with that technology. Yes, I brought through actually 3 slides just to give you some pictures. Maybe you could go on the last one where we show our, yes, this one exactly. Here, yeah, we started with the CHIC project, as said, with 5 buses, and then we went on with the JIVE project. Why does it? Why is it a good solution? Because as also Ify pointed out before, the handling of these buses, the operational handling is easy or quite easy. years ago, given that it was a disruptive technology at those times, the buses fitted in quite smoothly in the operational service and the day-by-day service. And this makes it clear how fuel cell buses on a difference to battery electric buses today still allows a not too strong change of operational processes and in order to have a zero emission public transport. So this easiness is the point that is really, really important and makes this technology, by sure, to have much more space than in the future, I will believe, than it is now said. The point is that you have to have a holistic approach. The problem on hydrogen is that it's still not available on a large scale and on as I say, on a price that makes the system sustainable, or better. There are already examples, and Northern Europe shows that green hydrogen is available now on a price that makes the running of fuel cell buses completely comparable to conventional technology buses. And this is the really good news on fuel cell buses, that the large interest on the technology, but mainly on the supply chain and on the production side, allows that at the end the public, the PTO is in a situation now to think of this technology really alternative to all other zero emission solution. It is important, as said, to have a holistic approach on the supply chain. This means we can go to the next slide, please. It's the newest, our newest buses, and yes, this is our depot refueling station and our new buses. And they are already on service since some months, so we have now a good experience also on the new buses. As I said, the holistic approach on the supply chain is important because PTOs should do PTOs, and the energy provider should be the energy provider, and everyone should focus on its own business and to enhance the competencies in its own core business. This will allow that the supply chain will work much better, and at the end will allow to arrive that scales that make possible that they will that this technology feasible on also not only on a ecological but also on an economic point of view. We chose to build the hydrogen refueling station on our depot because we plan a further enhancement, enlargement of the fleet, and in the depot logistic, this is the best solution. But I can tell you that at the moment that we made public this possibility, and with this the possibility to open the market on hydrogen supplier, the market has opened, and this is the really good news, that because there where market is, there will also be in a reasonable time prices that make the system sustainable from each point of view. And this is the main message I would share with you, because on fuel cell and hydrogen, technology. Mainly, you hear, yes, it's a good technology. It works. It is easy to handle. It would be. It allows not to struggle too much with other system, complicated charging systems of battery electric buses, but it costs. This is not as true as obviously if you also, for example, if you choose to change your fleet on CNG or biogas or whatever. Also, in that case, you will have to make a huge investment on infrastructure, and you will think about a large fleet in order to value the investment you make. And the same principles are true also for hydrogen and fuel cell technology. Obviously, if you buy HRS and you have in mind that you will have only 10 buses in your fleet, the total cost of the system are an enormous amount. But the point is that you have to look much more further, and you make your decision where your zero emission technology will go. And then the investment in hydrogen technology will be as comparable to other systems if you have to buy them from zero. And this is, I think, that the correct point of view in order to compare the technologies and also the choice. My invitation for all PTOs that are facing the decision and which kind of technology of zero emission buses they will have in our fleet, that they have to think big. They have really to think really big, and because small numbers will make no system sustainable. So I think this is the main message.
Okay, thank you, Miss Piff. Yeah, you've been very straight, asking about prices and about remarks to PTO about thinking bigger. Yeah, very appreciated. I mean, kind of message. We will be now focusing on the topic also of financial side with FCH JU. So I wish you a nice afternoon. Thank you very much, Ms. Piff, for taking the time to join.
Thank you. Thanks to you. Good work.
Yeah. Thank you very much. So we go back to the keynotes. FCH JU, the signature of this partnership, public-private partnership, is is placed on the main European projects on fuel cell buses, and the organization is here represented by Lionel Boileau. I put a question in advance. I saw in FS slides the target price of 650,000 euros as a goal for JIVE 1 and JIVE 2 projects. So together with your presentation, I will be asking, did you achieve this target or not yet? Please.
Thank you very much, Ricardo. First, do you hear me well? Do you see me? And most importantly, do you see the slide? Yes, I understand it's a yes. Okay, thank you very much for your invitation. The FCH2GU is a public-private partnership composed of the European Commission, the industry, and the research, focusing on bringing to the point of commercialization fuel cells and hydrogen technology. We have had a funding of roughly €1 billion, out of which 40% went for transport application. So for buses, trucks, cars, ships, airplanes, you name it. If I answer to your question, hydrogen buses, is it now? My answer is clearly yes, and be ready for your next ride on board the hydrogen buses. In the last 2 years, we have increased by 7 times the number of hydrogen buses in operation in the EU, from 50 to 350. Today, there are roughly 200 of them on the road, and the 150 will come by the end of the year, Q1 2022 maximum. If you look at the historical data, so I've put this diagram on the right-hand side. So you see back in the decade 2000 to 2010, if you look at the hydrogen consumption, kilogram per 100 kilometers, back in that period of time, it was roughly 23, 24 kilograms of hydrogen per 100 kilometers. 10 years later, this was divided by 2, nearly 12 kilograms of hydrogen per 100 kilometers. And the first preliminary result from the JIVE project that we see, it's roughly 6.5 up to 9.5 kilograms per 100 kilometers. These figures need to be developed and verified along the operation of the buses from JIVE and JIVE2, but it shows you that the technology is progressing, is advancing. And what I would like to say next is that people sometimes are talking about hydrogen buses as being prototypes. There are no prototypes. More than 15 millions of kilometers have been driven using hydrogen buses within the FTH2 project. That means elsewhere in the world outside the FTHJU, other millions of kilometers have been driven. For example, Ballard, a major fuel cell supplier, has announced some days ago they have achieved 100 million of kilometers on their heavy-duty vehicle, being trucks or buses. No prototype. More than 35,000 of lifetime has been reached by the fuel cell. That was in London for the buses and the ship project. The price target of 625,000 euros per standard bus has been met, and we have even seen offers quite below the 625,000, provided you order a fleet of buses, and that will be met. The availability of the buses, I don't have updated figures for the new buses under JIVE and JIVE2, but this has increased quite a lot in the recent months due to easier access to spare parts, dedicated maintenance pit at the bus depots, presence of fuel cell bus OEM staff on site at the bus depot. And on the infrastructure side, the hydrogen refueling station, HRS in short, have seen their availability increase above 99%, meaning that each time you go to refuel, the HRS is working. We see novel concepts of these hydrogen refueling stations, these being scalable, so from 20 buses to 80 buses in a period of 5 times, or when you expand your fleet, that's useful. Or hydrogen refueling station inside, indoor, the bus depot. Still, there are some challenges to get a full chain of service for the hydrogen management, where to produce it, who will do the distribution, who will do the maintenance of the equipment, and some work which is ongoing toward the harmonization of the standardization and the permitting of that HRS. Too often, in my feeling, we see local perception towards the construction of HRSs that take some time to be resolved. So we are working in making this faster for the benefit of everybody. Now, if as a PTO or PTA you would like to order fuel cell buses, the catalog is quite vast. There are quite a number of OEMs that have announced they have models of hydrogen buses available for you. They come in different lengths, size, double-decker, single-decker, 18 meters, tram bus in the case of Van Hool for Po, for example, 10 meters long bus in the case of Caetano. So all these European OEM are active in the sector. And of course, there are non-European OEM that are as well active. Won't talk so much about them. The FCH has not only been supporting projects, so providing funds for the acquisition of the buses, their operation, and the same for the infrastructure, but we looked at a long-term strategy, and we did 2 studies about fuel cell bus commercialization. One in 2012 that has shown that if we could put by the end of 2020 something like 300, 400 hydrogen buses in the European market, then the OEM, the Van Hool and so on, will have sufficient start to have manufacturing line dedicated to these type of buses. With JIVE, JIVE 2, we consider the 300, 400 buses are there, and therefore the market will expand. And indeed, this is what had happened, because in 2017, we did update of this commercialization study that has shown that the market, the appetite, the interest for hydrogen buses has significantly increased. And by 2025, you could say what 1,700 buses will be hydrogen-based. Still, it's a drop in the ocean, or I would better say, it's a glass of water in the garden swimming pool. Today, there are something like 40,000 coach and buses registered in Europe every year. So when we speak of few hundred, it's rather small. But this glass of water is increasing in size every year. That was for commercialization study. We look at policy for funding mechanism and dissemination. And I encourage you to apply, register to the next event, the Zero Emission Bus Conference taking place in Paris, 17-18 of November. One-stop shop website is the fuelcellbus.eu. One last slide of conclusion towards new business and financing models. In JIVE, JIVE 2, what we have developed was a joint procurement. It means that you have several cities, and instead of each of them ordering 10 buses and facing a negotiation with an OEM, you assemble, you merge, you gather the different cities, and instead of having 10 fuel cell buses at different suppliers, you go with a full order of 100 buses, and there you get the nice prices from the OEM. There you get the economy of scale. Another interesting model we've seen is the French one, where you have a central purchase office called UGAP. That means it's an entity that has a catalog available for public entities to order pens, to order cars, to order hydrogen buses. So that means the tender process is already made. So a French city could go at UGAP and say, I would like to have 10, 20 buses from the supplier listed in the catalog. Another setup that we have prepared, but it did not materialize in the framework of JIVE and JIVE 2, is a special purpose vehicle. It's more a financial entity where all the stakeholders, PTO, PTA, even the bank, the hydrogen supplier, create that special purpose vehicle, and it's allowed to share the investment risk between each stakeholders. One last point is the leasing of the hydrogen buses. It helps to reduce the acquisition cost, the capex, and it reduces the uncertainty at the end of a public transport concession, because today, given the low number of the hydrogen buses, there is no market for second-hand fuel cell buses. It will come in a few years, but it's not existent today. So, for example, you have Caetano, together with Toyota, that have put in place this leasing scheme. Few trends, cities are now ordering fleets of buses, 10, 20, 50, I would say personally, there is no limit, be ambitious, and it's no longer the time to test the technology. It works. These are no longer prototypes. We see fleets. We see zero emission tender, so it's no longer a choice of a technology. Cities will not say, I need to have battery electric buses, or I need to have hydrogen buses. No. Let the liberty to the operator, to the buyers, to offer you the best solution. It could be a combination of battery electric buses and hydrogen buses. We see an increased interest towards coaches and long-distance suburban buses, and this would be part of JIVE 2 to look at the demand, the appetite in coaches and long distance. And it's no longer the cities or the PTO or PTA doing the tender on their own who would like to have hydrogen buses. No, it's a much broader scale where we see hydrogen valleys, multiple users for this hydrogen. I would like to close by saying there is a European program called Connecting Europe Facility, CEST in short, that has opportunities for funding through the European Green Deal calls. And as well, the European Investment Bank provide loan at a very good interest rate should a PTA be interested in deploying hydrogen buses. So that's it for me. Thank you very much for your attention.
Thank you so much, Lionel, for your contribution. And it's a pleasure for me and for us to say that more than 530 people are following the webinar. So we are very happy about this. Now let's focus on the experiences and strategies of the public transport companies. The Netherlands, for instance, are a best practice in Europe in terms of energy transition in the public transport. In 2020, over 80% of city bus registrations there were zero emissions. Bart Kruiwanger has been involved for Transdev Netherlands in the implementation of the two largest zero-emission bus fleets in Europe so far at their time, with 43 e-buses launched in Eindhoven in 2016 and 100 in the Schiphol area in 2018. But how do fuel cell buses fit into a framework where most of the buses are already on the way to electrification? We know that your group is working also on the conversion of diesel buses into fuel cell ones, especially for long distance applications. Please.
Yes, thank you for your invitation. And here I am. And indeed, that's a good question because 25% of the public transport fleet in the Netherlands is already replaced by zero-emission buses. Most of them are battery electrical buses, and these buses will be in operations for at least 15 years because of the huge investment we have done. For the other 75% of the buses, hydrogen could be an option as soon as the TCO, the total cost of operations of the hydrogen buses, is at least equal to battery electrical buses. To get a better understanding of operating hydrogen buses, we are already involved in hydrogen projects since 2015. And at the end of this year, Transdev will have at least 43 hydrogen buses in scope with different technologies, which are the hydrogen buses with the dominant fuel cell, the electrical bus with a larger battery than those with the dominant fuel cell, with the hydrogen range extender. And we also look at retrofitted hydrogen buses. So for instance, we have an interesting project in Rouen in France, where we will retrofit intercity coaches which operate on a long distance route, probably the most ideal clean solution for such operations. In 2020, we came to the agreement on the conditions to retrofit a combustion Euro 5 bus into a fuel cell bus. This will be the first hydrogen intercity coach within our company. Also, the line where this bus will be operated is perfect to test the hydrogen solutions. It's a line between Rouen and Évreux.
But apologies if I interrupt you. I don't see the slide. I don't know if you were sharing them or not.
Yes.
I was not seeing so.
Oh, didn't you see it? Sorry, then I.
No worries.
You see them?
Okay. Now we see them.
Okay.
Oh, thank you.
Sorry, then you missed my first slide, but.
Yeah, but it was your speech was quite clear.
Yeah, this was the first slide.
Okay.
This is the second. So this here you see the slide of the project in Rouen, and it's the perfect operation road to test the hydrogen solution, because it's a line between Rouen and Évreux, which does 380 kilometers per day and 365 days a year with a very high average speed. So the ideal conditions to test hydrogen buses. After an intense period of preparation with all the parties mentioned on this slide, we will have the first dry run with this bus in this quarter of 2021, and we will start the operation with the retrofitted fuel cell bus in Q1 2022. So I think long distance lines with high average speed are the operations where hydrogen buses will be best placed. And that also is in the Netherlands, the future for hydrogen buses, I think. So this was my first answer on your question. Do we go to the next question immediately, or what do we do?
We will make a second round in a moment, but thank you. So, I mean, the topic of the splitting of the competences of, I mean, e-buses in the city and fuel cell buses out of the city, it is quite a common thing these days. I mean, fuel cell bus project started 10 years ago with a focus on the city application. We see most of the attention is being focused now on intercity, but not only this. There is also for city application in certain areas we see. So go back from the Netherlands to Dijon in France, where buses are just a little piece of the puzzle of a wider commitment of the city for the creation of the hydrogen ecosystem. We have here Thomas Fontaine, which is managing director in Keolis Dijon. So Thomas, may you outline which are the reason for this choice and the roadmap you have until 2030? So please.
Yeah, good afternoon, everybody. So pleased to have the conference with you. So here in Dijon, we have got a plan where we operate different mobilities, meaning that it's a full mobility, a mass mobility contract, mobility as a service. So we operate for Dijon Metropole, 2 trams line, hybrid buses, 102 hybrid buses since almost 10 years, and bicycle and all regarding street parking and car parks. And it gives the opportunity to have a really, as you mentioned, Ricardo, a really complete vision on mobility. And the first contribution to environment aspects is the fact that we have got a high level of model report from the car to tram buses, clean buses, we'll speak about that, and to have a really integrated mobility system. As I was mentioning, since 10 years, we operate 102 hybrid buses. And with this operation and tram operation, we are reaching now the level of 85% of clean kilometers done on Dijon network, which is really a high level of operation in terms of environment, and gives really the good habit in Dijon to have to be really friendly with the environment. It's one of the best figures in France and in Europe. If we go to the strategy regarding what is focused on a hydrogen system in Dijon, maybe just a few words about why Dijon is developing this hydrogen ecosystem. Dijon wants to be in the next years the first hydrogen city in France and one in the first of Europe. In terms of size of fleets, so we speak about the conversion from the hybrid buses and diesel buses fleet to all hydrogen buses in the next 7-8 years. So we speak about 200 vehicles, and as we can see here on the slide, the aim is to save per year around 1.75 tons of CO2, which is a really high level. So the program already begins with hybrid buses and with the trams, but we are still in this plan within Keolis Dijon Mobilité in Dijon to develop this plan. The second part is to have, as I was mentioning, a complete ecosystem, meaning that we will work with integrated production. We speak about green hydrogen. So all this hydrogen will be built with a local development, meaning that we'll use concept of garbage to wheel. I will explain you that later with a schema, meaning that we will use the waste system in the dedicated plant to build process to build green electricity, and after to build electrolyzation of hydrogen. And in the meantime, we'll use photovoltaic farm to have all this system with green hydrogen. It is really interesting because we will have the development of the fleet, hydrogen fleet, and the production will be green. And a sub part on this program is that we want to have all the transfer of the hydrogen technology to our teams, meaning that we are working now with OEMs and working with the companies who are producing and developing the project in order to have a transfer of the technology and to have really a good knowledge of the behavior for vehicles. It will give us the capacity to increase the life cycle of the vehicles. It will give us the capacity to, in partnership with the OEMs and the industrial, to optimize the consumption. And that will be really key, because as far as we can optimize the consumption, we'll be really able to reduce the level of consumption and to reduce the total cost of ownership of the system. So it's really the part that where today we want to work to have green hydrogen and to have a high level, to reduce the level of consumption, in order to optimize the total cost of ownership. There will be two phases of the program. The first phase in the northern part of the city, where we'll have 4 distribution stations for garbage truck. So 4 garbage truck and 10 buses. That's the first part. Will begin next year. And after, in the next 2 years after, we'll have around 175 distribution stations for the bus fleet and even for garbage truck and some service truck in the city. That's the part that I was mentioning before, where you can see the city of Dijon on the right. And so we'll have a complete ecosystem and localization for H2 system, where we'll be able to supply energy to for in the future, in order to supply coaches to, and will be far around Dijon. Will give the capacity to have suburban lines with hydrogen system. So the system of hydrogen program in Dijon is starting in Dijon with green production, and after we go around and develop further and further around the city of Dijon and all the land around. Just going back of the way of production, of the green hydrogen production, I was mentioning that. So it's really the process of garbage to wheel. It's a kind of circular system where you've got for the waste system, then you produce the electricity, the green electricity, and you supply to garbage truck and supply to the buses the energy. After we'll use photovoltaic too, and we are looking for in the future, well, we'll develop the fleet of buses to have other green source of hydrogen in order to supply the system, meaning that we are working on some approach on biomass, on green electricity too. And it's really the capacity to go progressively and to develop the system in the next 7 years in order to always have this balance between the increase of the fleet and the capacity to have a green hydrogen production. Just to give you here an approach about the fleet. So first phase, starting now, 8 garbage truck, 27 buses. We are almost to conclude the bidding process in order to choose the happy manufacturer for the buses. Working with experienced manufacturers. Has been a kind of really strong competition on that. It has been interesting, and we have seen different interesting technology, meaning that there is maturity arriving on hydrogen buses, and that's really a good news. And when we focus after in the year between 2024 and 2026, the fleet of garbage truck will increase with 14 garbage truck more, and we see that we'll have articulated buses, 18 meters with 35 buses. And then if we go after, the next phases will be for the rest, meaning 130 buses from 2026 to 2030. To be clear, it will be the replacement of the hybrid buses, which will be around between 17 and 18 years at this moment. And we are working on the project, and that's what key point of success in Dijon, with the management and partnership of Dijon Metropole, so which is the city, and we are really giving, as a major stakeholder, giving all the orientation. And we work closely together with Rougeot, which is building the station, electrolyzation station, and has got a part which is called Rougeot Energy, all regarding engineering for the electrolyzer and the station. Within Keolis, we are supplying all the engineering, the process to buy buses, and the process to develop the complete ecosystem for all regarding the maintenance and the engineering for buses. In the meantime, we'll develop within the schools and university engineering school around Dijon complete trainings around hydrogen. And this training system will be a part of the Keolis campus we are building here for new transition buses, and especially for hydrogen. And we work too with JIVE. JIVE is not a musical part. It could be a musical part, but it's only the operators of garbage truck we are working with. and closely together with JIVE, so part of CEST group, with Keolis, we work on the integration of maintenance, and reason why we are looking to have all the transfer of technology, and we will have a common warehouse and common plant in order to maintain and to develop all the equipments on hydrogen technology. Just to conclude and to give you a global map and overview about what will be the program. So there is different things about the project life cycle. We are still in the end of phase of development and the construction of the station, and working on the supply of H2 for with next year. It's a 20 years program for supply of H2, so we have got time in front of us. If we speak about the development, what we are working to as an innovation will have for all the buses bus place supply, meaning that we won't have a dedicated station at the entrance of the depot, but we will have for each buses will be parked, and after the hydrogen supply will be done during the night shift or during the time that will be developed for that. And that's a new innovation we are working on. Right now, we have this Dijon Metropole program has been launched for the construction of the northern Dijon station, and the southern one is about to be launched too, and everything will be ready for the first buses end of 2022, and after for the second batch of buses 2023. So it's really let's say a pretty quick program we are developing, and we'll have this progressive development of the fleet. And right now, just to conclude, in the meantime, if we speak about the bus fleet, right now we are about to conclude the contract. We are already working on the transfer of technology. I do insist on the work we are doing with all the university and schools in order to make the training. Our team of driver and maintenance are going in training right now. We are developing the training with the engineering school. And in the meantime, we are working too on the integration on the city of the new network with hydrogen buses, which is something important, and the development in front of all our customers to give this new vision with hydrogen buses in the city of Dijon. And that's part of the program developed as a green city with by Dijon Metropole, and we are partner as Keolis Dijon Mobility of this program. That was just to give you to answer to a question, Ricardo, and to give you a global overview about what is the strategy of Dijon Metropole in regarding hydrogen systems and the ways that we are answering closely together with Rougeau, Diaz, and Keolis.
Thank you, Thomas. I think we're running out of time. Sorry, but we will come back to you later. Now we are glad to have with us Wolfgang Reitmeier from the VDW, the German Association of Public Transport Companies. Wolfgang, may you give us a picture about where is Germany standing in the field of hydrogen buses, and which are the expectations for the upcoming years? Also considering the highly ambitious German national strategy on hydrogen, please. Wolfgang?
Yes. Thank you, Ricardo, for the introduction and for the opportunity to show the German situation and the position of the VDW. In Germany, we are facing a great challenge. We are planning to switch off all gas and coal-fired power plants and also all our atomic power plants. So that's why we must produce all energy we need by renewable energies. And in the first slide, you see the energy consumption of Germany. And you see we have most energy we needed is made from oil and from gas, a little bit also from coal, and about 20% of the electrical energy is a part of the energy, and only 6% of the total energy consumption is made of renewable resources. So that's why we must save every kind of energy to make electrical energy from it. So to hydrogen would be a very expensive energy for us in Germany in the future. So the efficiency of the whole system is very important for us. So that's why we see the city bus with a battery drive is the right solution for the ordinary cities. And for special purposes, we need the hydrogen. So for long ranges or also for very strong topographies, we will use hydrogen bus in our city. And one more problem is that we have in Germany not so much bus suppliers on the market. So we have only Caetano, Van Hol and Solaris available. And soon we will have EvoBus available, fuel buses from EvoBus available in Germany. At the moment, we use around 1,000 electrobuses in Germany and around 50 fuel buses in Germany, by a total use of around 40,000 city buses in Germany. So you see the part of the fuel cell bus is very low at the moment. So the availability of fuel buses is also a problem in Germany. A lot of bus operators are very much interested to use fuel cell buses in their companies, but we also have not so much infrastructure for fuel cell buses. So to the conclusion, the environmental legislation requires a significant reduction in emissions by 2030. The hydrogen infrastructure will not be established until 2030 at the earliest. The national hydrogen strategy only provides the use of green hydrogen obtained from renewable energy through electrolysis. So the national hydrogen strategy is very strong to use only green hydrogen for public transport or also for all other hydrogen users in Germany. So the green hydrogen is only made by renewable energies with electrolysis. So it's very hardly to make this in Germany. The demand for green hydrogen, for which there are no alternatives, example in the steel industry, shipping and aviation, will increase significantly. Hydrogen technology is still at the early stages. There are few providers of e-buses with fuel cell drives and hardly any system expertise for fleet operation. Battery electric drives offer the lowest TCO values. Many requirements in public transport can be mapped with current and future batteries. This enables a short-term start to emission-free mobility. Bio and synthetic fuels as low emission fuel as well as hydrogen for emission-free vehicles offer alternatives. So thanks for your attention, and I will be ready for the next questions.
Thank you, Wolfgang. A very clear message to OEMs, to manufacturers who are now listening. Also, the topic of energy efficiency will be surely addressed in the next contributions. You mentioned the topic of TCO, so battery electric and fuel cell buses will focus on the TCO. I'm now starting a second round with the request of being very quick, as many people still have to talk. Start with Bart, Transdev. So you had quite a long experience, both on mainly on e-buses, now on fuel cell buses. So may you help us doing a kind of a comparison on a TCO basis between battery electric and fuel cell buses? Thank you.
Thank you, Ricardo. What we see of what our experience is in the Netherlands is that the total cost of operations of a diesel bus and the battery electrical bus are coming very close to each other. But what we also see is that hydrogen is still much more expensive than the battery electrical bus solution. And that's also why most of the hydrogen projects nowadays are subsidy driven. What we see is that the total cost of operation of a hydrogen bus is up to 60% higher than that of a diesel bus. But the difference is also what we see are getting smaller. So we see a lot of developments in the market that will bring the total cost of operations closer together. The developments we see are on one side, those on the fuel cell. We see that the suppliers of fuel cells are developing fuel cells that will have a longer lifetime. So you do not have to replace the fuel cell during the lifetime of your bus anymore. The fuel cells will be less expensive than they are today. And also the maintenance costs will drop. And those fuel cells also will have a higher efficiency. So you need less hydrogen per 100 kilometers. So that's the other side, which will lower the total cost of operations. And the other side is, of course, the cost of the green hydrogen. We see that the demand for green hydrogen will increase in the future. So there's more demand, so more production. So we expect that the price will go down. For instance, nowadays we pay 7 to 8 euros per kilogram on hydrogen, on green hydrogen. And we need a price below 5 euro to get the total cost of operations from a hydrogen bus as equal towards a battery electrical bus. So my conclusion is that the hydrogen buses will get competitive within the 3 to 4 years at least. And that's important because I think we need the hydrogen, as also we need the battery electrical buses to meet the numbers from the Paris Climate Agreement in time as well. So we need both technologies to reach the Paris Climate Agreement's figures. Thank you.
Thank you, Bart. Thank you very much. Now let's go back to Dijon, Ricardo, and ask Thomas, which is the business model behind the project you have been telling us before? Could this be a kind of a pilot scheme for fuel cell bus deployments in the future?
I think it could be. I mean, after it's always we always need to be really modest in when you have got a model saying that it could be one way of model, and right now we are working closely together with other operators, and Dijon Metropole is working with other PTA on this model. Regarding the business model, the first key part of this business model is there is a project society, including, as I was mentioning before, as partnership, Dijon Metropole, so the public transport authority, including two Genie Civil company with engineering, and including operators for the station, production of hydrogen, and including us as an operator of mobility. So at the beginning of the project, when the decision has been taken by Dijon Metropole, 2018, we are beginning to work together as a platform. We have got here a local physical platform where all the society, I mean, all the stakeholders are part of the project. And that's one of the key things, and the way that we are working on. And this program and this way of working is developed right now. And if we speak about the business model, we really think that we need to work really in anticipation with the OEMs, with the production. We have met all the technology supplier for fuel cells for the buses since 2018, and we have developed this really anticipation and innovative model. And the last part is, I was mentioning before, we know that H2 has got a cost as production, and so we are beginning to work already about the way to reduce all together, all the partners, the cost of H2 as production and the consumption of H2. So it's part, as a summary on that, we need to anticipate with all the partnership together and we need to focus on the life cycle of vehicle and on the global cost, the total cost of ownership of H2. That's the key of success.
Thank you very much, Thomas. It's very sad to say, but I mean, if the diesel prices will keep on rising as in these days, maybe the break-even point with hydrogen will come very closer, because I mean, prices are striking it all over Europe. Wolfgang, VDV, your position covers the topics of depots and workshops. So I would like to ask you very briefly, which are the most significant challenges for public transport companies, for your members, when they are turning to fuel cell bus technology or zero emission technologies, please?
One of the biggest challenges will be to introduce all the infrastructure in the depots. So that's a big challenge for us for the storage for all the hydrogen, and to build all the filling stations for the hydrogen, and to produce all the hydrogen by the renewable energy in the future. So we have, as I said before, the green hydrogen would be very expensive because it's needed by a lot of other industrial parts, maybe for the steel industry. So the hydrogen would be, I think the hydrogen would be too expensive to use it in the public transport if we could also the electrical energy.
Luca, guarda, io aperto. Yeah, Wolfgang?
Yes.
Okay, thank you very much. So, yeah, many issues have been provided from the operators session. Most of this will be now surely part of the next session, the one of cost, the one of energy efficiency, the one of infrastructure. And I mean, I would say it's very nice to have in front of us at this moment kind of the chain, the industrial chain of fuel cell buses represented, because we have a global group focused on storage, on tanks, on transportation of hydrogen, on materials. A fuel cell modules provider, the main fuel cell module provider, e-drives supplier, a bus builder, and finally a telematics monitoring company for public transport. So let's start from the very beginning. We asked to Radisa Nunic for Worthington Industries, which are the challenges today in storing hydrogen, and which are the safety measures also put into play. So please.
Well, good afternoon, everybody. It's a great honor to be part of this webinar today. Well, coming back to your questions, the challenges we face as a manufacturer of fueling systems or car storage solutions are mostly related to the raw material availability and costs. Over the recent months, we have seen extremely high, let's say, rising costs of the raw materials itself, but also of the transport rates, which have been exploding since the corona hit us. As far the availability, let's say, as such is concerned, it is everything about the planning, long-term planning of the demand, and also about the having the right partner to do so. Having the right partner who is going to design and concept the fueling station, but also the one who supplies you with the cylinders. The fueling station itself and the cylinders are de facto safe. There are so many regulations that needs to be followed in production of the cylinder, but also in the assembly of the fueling stations. And in general, they are safe. The only thing that can happen is some kind of human error, which cannot be excluded from any business in the world. We have seen that the deployment of the hydrogen stations is ongoing, and we also understand that the bus depots, municipalities who run the buses, they have a completely different questions and issues around the fueling stations compared to the public stations for the cars. And the good side of this one, let's say the positive side of this, everything for the depots, well, since those companies usually know how many buses they are going to employ, they can better calculate the business case and also arrive sooner to the final total cost of ownership and operation of these vehicles. And we have heard today from colleagues from Netherlands what is the target price for the hydrogen to make this a viable solution. So we have also price of hydrogen, we have price of the vehicles. Price of the vehicles is going down. I can also very much underline, which Ms. Fischer has mentioned today, it's about the scale. We have got enough vehicles in our order books, then we can offer better prices. And when it comes finally to hydrogen filling stations, one more time, if we achieve higher grade of standardization there, the cost can be reduced further, which will help us at the end of the day to drive down the total cost of ownership.
Thank you, Radisha. Thanks a lot. So now let's go forward in the value chain and try to take a look into the future with fuel cell modules provider Ballard Power Systems. David York leads the Market Development Office in Europe. Focusing, of course, on the bus segment, how do you see the future evolution of the market? More focus on city applications, intercity applications, and what do operators need to consider when deploying their first fuel cell buses and the impact of these buses on a mixed fleet? Please.
Yeah. Hi, thank you for having me here. As far as the sort of current deployments of fuel cell buses, I think we've seen from the previous presentations, most of the buses are in a city deployments of buses. You can see that with the JIVE project of the buses that are running there, a very, very important project. And what the benefit of city buses are is that they are back to base operations. Therefore, the fueling infrastructure has to be in one place, and so they're quite easy to deploy. I see in the future, I think we'll get more intercity type deployments, but you have to remember that buses are quite different to coaches. So when you take coaches, that's a new element that we have to put in. But there's also a different element where we may have to have base-to-base fueling infrastructure, or even fueling infrastructure on the general main routes that you can use the buses. So your fueling regime becomes very different when you talk about intercity, or could become very, very different. There are still back-to-base operations. As far as deploying fuel cell buses is concerned, there's really three elements to remember when you're deploying a fuel cell bus. There's the bus itself, there's the fueling, and one area that's often not mentioned is the maintenance. Now, we've spoken quite a lot about the buses today. We've spoken quite a lot about the fueling, so I won't concentrate too much on that. But as far as the maintenance is concerned, there are some elements that we have to take into account, and sort of workshop adaptations that we have to do. But obviously, when we're talking about maintenance as well, certainly in a bus depot, even in a traditional bus depot, safety is of paramount importance. And obviously that doesn't change if you're using a hydrogen fuel cell bus. But when we're talking about safety and the safety deployments within a bus depot, we have to keep the messages very, very simple. So in a sense, remove what is hearsay and thoughts of people, and put in the right safety messages. There could be some sort of workshop adaptations to go on, so some sort of hydrogen detection, possibly some venting in there. It would all have to be dealt with by risk assessment, and obviously looking at local regulations. But also we have to think about a lot of training, and that's not just training for the technicians that we've got, it's also training for the rest of the depot, because in a bus depot you have a lot of interactions with people that I'm sure some of the operators know about. You have the technicians, you have the drivers, you have the management staff, and generally you could even have the sort of general public you may have to trained to a certain extent. But when we're also talking about the safety message, we have to remember that there's not just the hydrogen is not only the safety element we're thinking about. There's also the high voltage that we've got, and we've got that on battery electric buses. So nowadays, I think a lot of technicians would already be trained to deal with the high voltage elements of the bus. And we've also got high pressure, because the tanks that we've just or that have the gaseous storage of the hydrogen, they're at high pressure. So we have to have training around that. But the beauty of a fuel cell bus over a battery electric bus is that it can be a drop-in replacement for a diesel bus. And with a battery electric bus, this may not be the case. So we have charging that we have to do, make sure the buses are connected to the chargers at night. But with a fuel cell bus, we can keep our depot processes the same. So bus comes in, fueled, cleaned, ready to go in the morning. So that could be a big advantage in a workshop and in a bus depot. So there are a lot of considerations of the fuel cell itself. We can think of the fuel cell as is the source of a fuel cell electric bus is an electric bus, but our source of the electricity is coming from the fuel cell. We do have preventative maintenance procedures on our actual fuel cell itself, but this can be fitted in with the normal bus maintenance regime that you already had. So again, it can become a drop-in replacement for a diesel bus.
Okay, thank you, David. Yeah, the topic of fuel cell buses as a one-to-one replacement of diesel buses, and as a way to keep procedures in the depot like they've always been. It is quite I mean, a common feeling with the e-buses. We see bus operator must think a little bit like a rail operator at this moment, planning and replanning their network for, I mean, to enable the charging procedures. Siemens has a long experience on both, on drives for e-buses, for fuel cell buses, for zero-emission commercial vehicles in general. We have here Eugen Hall, who is the responsible of the R&D department in Siemens commercial vehicles. So we would like to ask him, where do you see this market going? Which direction?
Hello to everybody. Thank you for having me, and a warm welcome to all the participants. Very clear, it goes further electric regarding the propulsion system. Sooner or later, we see all commercial vehicles having electric propulsion systems. And I want to share a story. I was living can you hear me? Hello?
Yes, we can hear you.
Okay. I was living 5 years in China, in the city of Shanghai, and I was actively working and experiencing how a city changed from diesel buses to electric buses. Now in these days, I think they are almost at 100% electrification rate. And it's not only the global CO2, it's also improving the city with emissions as well as with noise. And it's improving significantly, I think, our city. So I hope, and I'm sure that will also bring a strong growth to city applications in Europe and North America in the years to come. And from I think 2025, we see also the growth in long haul, that means truck and coach applications, with a stronger growth after 2030. I would like to discuss a little bit about the energy source as well as the propulsion systems, if it comes to these two different applications, city transport and long distance transport. For city vehicles such as buses and regional delivery trucks, I see the majority will be battery-based zero-emission vehicles. The reason for this is the significant better energy efficiency. And this means lower TCO and faster payback, what we already heard this afternoon as well. However, fuel cell technology is important, and they can gain market share also in cities, especially where advantages of the overall hydrogen ecosystem can be used. On long-haul vehicles, it depends on range and infrastructure, whether battery or fuel cell technology will be the best solution to take. Other concepts like e-highway from our mobility colleagues is also an interesting option, especially if it comes to energy efficiency, because here they are almost the best, or at least very close to batteries. However, the infrastructure topic need to be solved, and that is the issue with this, in my point of view. However, we are a drive system supplier, so this is not our main issue. We focus on propulsion systems and how this will change if you look on the different markets for city applications as well as long distance. So generally, we have electric axles with and without shifting gears, where motors are integrated into the axle, or we have the so-called central motor design, where motor or combination of motor and transmission drives the cardan shaft. For low-floor city buses, I see they will go clearly to low-floor electric axles, because the electric chassis in the electric chassis, you can generate more degree of freedom for the layout of the bus and their users. Due to limited speed and power of these vehicles, there are no shifting gears required. So fixed gear ratios will do it and get an overall good solution and results regarding performance, efficiency, costs, which is very important KPIs. For other markets like low entry and high flow city buses or trucks, we see also the central motor have a very good opportunity, a good future, because there's no significant disadvantage between a central concept and electric axle. And due to easier standardization, higher volume, they will also offer, in my opinion, better costs. For long-haul trucks, especially here in Europe, we see mainly the two-axle trucks, the two-axle vehicle with two axles. They will and have to go to electric axles, because the main reason for this is that they need space in the chassis to mount the battery as well as the fuel cell in case of a fuel cell hybrid, and they need to be installed within the chassis. So there's no space for a motor anymore. So the motor must go into the axle. Central motor transmission solutions we will still see for the time being, also in those tractors, but together with some compromises of range and or power. Long term, this technology most likely disappear for those truck tractors, at least for the two-axle ones, but it's still a competitive solution for regular rigid trucks or coaches, where space below the frame is normally no issue. So this is how I see the market if it comes to propulsion systems.
Thank you very much, Eugen, also for mentioning trucks and talking about powertrain and technology on a different side, we can say. Now, let's switch to bus manufacturers and to Caetano Bus, which is among the bus builders which are investing heavily in zero-emission technologies. In 2019, the H2 City Gold was introduced, while 2 years later, the first batches of vehicles were put on the road. Paolo Marques from Caetano Bus, which are the main challenges for a manufacturer when approaching the fuel cell bus segment, and which are the main issues coming from customers according to your experience, please?
Hello to all. Thank you for the invitation to be present. The main issues, mainly on the product side, were in the beginning the kind of validation conditions, as you know, in south of Europe, stations are missing. So hydrogen stations are missing from let's say for the deployment point of view. So this first deployment was very tough in our country for sure. In Portugal, the first two vehicles were deployed last July. So that's why it was very tough to start from each even from our country. but we start already deployment hydrogen vehicles in Germany, France, and there will be deployment in the next months in Spain and Denmark and the Netherlands and Germany. So as soon as more stations will be available, we see that the deployment difficulties from the operators have the availability of the stations to try our products. It will be solved. As much as vehicles we will sell to our customers, and the customers will test, as much as they will test, they will be more confident in the hydrogen solutions and technology. And the point is that all of these vehicles have, as Siemens, the colleague from Siemens already spoke, we use electrical chassis, electrical powertrains. So battery vehicles or hydrogen vehicles, they share the same chassis, they share the same platform. It is just a matter of different way of feeding the energy on the vehicle. And these were, let's say, the main difficulties that we face from the product side. From customers' difficulty, the issues were raised already by Ballard, that workshops needs to be changed. The teams needs to grow their knowledge on technical field, on the hydrogen systems, on high pressure systems, because sometimes if you change a bus from the diesel to hydrogen, you need to figure out that two steps needs to be made. First step, to change the technology from the diesel to electric, and then from the diesel to hydrogen. So in this case, the technical teams needs to have the expertise from the high voltage systems and hydrogen systems. So from the point of view of the operator, changing from the diesel to a hydrogen vehicle is quite convenient, because the downtime that normally electrical vehicles have for charging, it will be much more lower, and the downtime could mean 20 minutes a day. But when it comes to hydrogen, the technical capabilities in the workshops, in the infrastructures, and in the workshop teams, the knowledge needs to be increasing. So technical knowledge, I will not say that is more difficult one area or another. I just say that it's a different knowledge that should be growing, should be growing from the technical team side. So these basically are the two main difficulties that we face during the last 2 years. But as soon as we have more and more customers and more field experience, we believe that the hydrogen, it will bring us the liberty that the diesel already shared with us during these last years.
Thank you, Paolo. You mentioned the skills are evolving, competences are changing inside bus operator manufacturers. One of the competences which is becoming crucial in the last year is IT telematics. So we're at the end of the chain. The bus goes into operation, and the fleet monitoring come into play, into the match. So VeriCity is a former startup from the Netherlands who took a leading share in the market of fleet monitoring of buses and trucks through telematics. We have here Alexander Schaber, who is a co-founder of VeriCity. So Alexander, how does the complexity increase when you add a few fuel cell buses in what becomes really a mixed fleet with many drivetrains involved? Please.
Yeah, hi, Ricardo. Hi, everyone. Thank you very much for me that I have the opportunity here to speak today. Thanks for the question. I see 3 key points. What changes if you add additional fuel cell buses towards a mixed fleet? And 2 of these key points on the vehicle side. The first one is on the maintenance. The more technologies you add, the more complexity you will also create for the maintenance teams. So if you have, for example, diesel vehicles, you have battery electric vehicles, and now also fuel cell vehicles, then all of them have different key components. And as you know, for the battery electric vehicle, one of the key components is the battery. You need to monitor cell temperatures, cell voltages, state of health, to get a good understanding of how good your battery is at the moment. Now, the difference between a fuel cell and a battery electric bus is that you still have a battery on board, a little bit smaller lithium-ion battery, but therefore you add the fuel cell and the hydrogen tank. So if you then look at the fuel cell bus, it's next to the battery, also the fuel cell, which is the next critical component. And similar to a battery, a fuel cell also shows some degradation over time. So if you look at a fuel cell stack consists out of individual cells, and in these individual cells, you see this degradation. So therefore, it's really critical to monitor also fuel cell buses, especially down to a cell level of a stack, to understand what's, for example, the cell temperatures, what are the cell voltages, what is the output in terms of power, to really understand how good the fuel cell is still performing. And I think this is critical for maintenance in general, to make sure that you can operate your hydrogen buses in the same way as your battery electric or your diesel buses. Now, my second key point is more on the operations. If you look at fuel cell buses, they also have a limiting range. So it's also critical here to look at the hydrogen level and to get a good understanding how much range is still left, because the complexity is a bit higher than if you just look at a battery electric bus. There you basically just need to look at the state of charge. You need to look at what's the energy consumption, and therefore you can then translate the remaining range. Now, at a hydrogen bus, you need to look at the hydrogen level. You need to understand what the pressure means in terms of how much kilogram of hydrogen I still have. Then you need to look at what's the efficiency from converting that hydrogen towards electricity that then gets stored in the battery. And then how much range do I get out of that from driving with the battery? So this is quite a complex task. And there it's also crucial to get real-time information to help the operations team to make sure that also all vehicles have sufficient range. Now, my third point about how the complexity increases with adding fuel cell buses is more on the infrastructure side. And there, if you look at the refueling process, hydrogen does require a new infrastructure. However, the refueling process is more similar to a diesel vehicle. And that definitely has certain advantages. The complexity that you do add with it, if you now have, again, let's say diesel, battery electric and hydrogen vehicles, is that you have different processes in the depot. Every bus requires something different. And therefore, it's also crucial to understand which bus will be used on the next day for which service, which bus will be parked where, what is the range that each of these vehicles can do. So on the infrastructure side, you also need to add some software to get this better under control. And therefore, especially a depot management system are crucial systems to have to get a better understanding how you use every bus type optimally.
Okay, thank you very much, Alexander. Now, we are going to start our very last round of questions for today's webinar. And we go back to Radija Nunic from Worthington. We have been discussing a lot today about hydrogen buses for long-haul applications. This is mostly a matter of infrastructure's capability and hydrogen's production. So, Radija, where are we standing now? And in the framework of the Next Generation EU, how do you expect this issue will evolve in the future, in the near future?
Oh, that's a very good question, but the answer is quite simple. We know today that the European Union is absolutely committed to hydrogen deployment in the EU. So there are basically plans and, let's say, strategies to put a hydrogen fueling station every 150 kilometers along the main transit roads, but also in every single city. Well, in that case, the long-haul application starts also with the design again of the fueling station, because today available fueling stations have not been designed for large quantities of hydrogen, meaning for the heavy-duty vehicles and or buses. Then the next question, which needs to still be addressed, is let's say the choice of the technology utilized, because for the long-haul application, is a bus or is a truck, we hear often in the last, let's say, months and years that we are going to go direction 700 bar fueling systems, meaning cylinders and other components. And or like Mercedes, Daimler is following the strategy of liquid hydrogen. As far the gaseous tanks are considered, vertically set and prepared for 350 bar and 700 bar technology. And as far the hydrogen in liquid form is concerned, well, that's in our eyes still far away future, because the electricity needed to liquefy the hydrogen is much higher compared to 700 bar compression. But still, we see that all of these technologies will become part of our daily lives in the years to come, and we look really forward to this one. It is also important for me to underline that all of these challenges we need to see as opportunities. See it as an opportunity to learn to decarbonize faster our transport. And when it comes to hydrogen production itself, we should not be discriminating other forms of hydrogen, because it is going to take many more years that we are set and ready to go with the green hydrogen. I'm not saying that we should be focusing on utilizing let's say for decades in front of us other forms of hydrogen, but we should use the hydrogen which we have available. Again, Netherlands is a very good sample, but also cities around Cologne or Cologne itself are utilizing byproduct hydrogen to fuel their buses. The goal is to decarbonize fast using let's say, the gas we have on our hands while we are preparing for green hydrogen future.
Thank you, Radiz. Yeah, also in the framework of the energy crisis we are seeing today, we know hydrogen is really good also for building local, how to say, local chain. Yeah, local chain of hydrogen produced from a local situation, as Keolis shown it is doing in Dijon. It could be kind of a model for the next year in the future. Going to Ballard. So David, can you try to give you from a global perspective this time an idea about which is the size of the fuel cell market and how fundings today impact on the deployments, please?
Yeah, we've already heard figures in earlier presentations today on the numbers of buses that we have on a global scale. The numbers of city buses and buses is phenomenal. I don't have the number, but in UK alone there are over 30,000 service buses. So if you have to decarbonize all of those, we've got a very big job to do very, very quickly. And when you take the number of zero emission bus deployments, whether that be fuel cell buses or battery electric buses at this point, it's very few in comparison to the total number of buses that we have. The ambition is fantastic to go zero emission, and I'm all for that, but the challenge is big. And I say it's a challenge, it's a good challenge, but it is a challenge to get there. At Ballard ourselves, we've already deployed with Ballard Power over 1,300 service buses, and as was said earlier, we've operated over 100 million kilometers, not just in buses but in heavy duty vehicles. So we're very ready to take up this challenge. But most of the buses deployed so far have been done with some funding, and we've heard from the FCHJU with their projects, and I've been involved in the SHEEP project, the Clean Hydrogen in European Cities project, the 3Motion project, environmentally friendly efficient electric motion project, and not directly involved, but know very much about the JIVE project. And the good thing about these funded projects is they all build on each other. But what's very important is the lessons learned from the initial projects are implemented and grow into the later projects. And I think in the next few years, we will be changing and there's some analysis being done on this, we'll be changing from more of a funding model to more of a pure commercial model as the price of fuel cell buses come down. And at Ballard ourselves, we have a roadmap to cost down that we're working on. But also alongside this and funding, there's over 50 countries that have already stated they hydrogen strategies for the future. So with those strategies, alongside often will come funding, which is welcome. But that can change from country to country. So sometimes the funding is more hydrogen focused, sometimes more vehicle focused, sometimes a bit of both focused. I don't think it matters so much, but it's good to have funding. So I think in the future, we are at the moment, as Bart said earlier, we are subsidy driven, but I think the future, very soon, the TCO cost of buses will come down and we'll get into a more commercial model. The one thing I would say, being in the fuel cell business, is that when funding is available, I would like to see funding there, especially the sort of national funding, that if they're talking about zero emission, that there isn't elements in the funding that eliminates fuel cell bus, that zero emission is not a technology, it's for any zero emission vehicle that's out there. It's not just pointed towards a certain type of technology. And I think that's important for the future. I think the numbers we've seen, and we've heard it a couple of times, sort of 10%, 12.5% of buses being fuel cell buses. I have no reason to dispute those figures. I think possibly they're on the lower side. There are other operational reasons why you might want your whole depot to be one technology or another technology, which could change those figures somewhat. So there's a lot of things going on. And I think the ambition of countries and funding is excellent, but I think we're moving very quickly, and in the next few years we'll have a very different landscape from what we see now. But that is thanks to a lot of the funding activities that have already happened.
Thank you, David. Thank you once again. Now let's move back to Siemens and Eugen, and take advantage of his position as Vice President, Research and Development at Siemens Commercial Vehicles. Let's talk about energy efficiency, which is always a key issue when talking about e-vehicles. So our question is, which are the issues or the innovations you are working on at this moment?
Thank you for the question. We have a clear target for our product and system development where lowest TCO is #1 priority, and energy efficiency is a big portion of it, next to long lifetime or maintenance or reliability, and of course also costs. If it comes to energy efficiency, the individual efficiency of motors, inverters plays an important role, but also the whole control algorithms, the motor control itself, to bring the design efficiency of motors and inverter hardware also under dynamic circumstances on the street. But also elements like optimum electric braking play an important role in the overall energy efficiency of an electric vehicle. And energy efficiency you cannot only see in the operating costs. For big volume products, if you consider cars or trucks, you get it directly already in the capex, because the vehicle is not designed for a certain kilowatt hour value per kilometer. It's designed for range. And if you can do this with less kilowatt hours, you save, for example, in a battery vehicle from the beginning, batteries, weight and costs. And so it's maybe in some applications already possible from the first day of the use. So for motors, we clearly focus on permanent motor technology for commercial vehicles. This is for city buses with a special inner-city driving cycles. But according our opinion and knowledge and experience, we also see clear advantages for highway trucks, even they run dominantly in the higher speed area. Besides efficiency, also power and torque density are important KPIs, which can achieve best with permanent motor technology as well. Finally, I want to talk about new products. As our CEO, Mart Verschoor, already published during the summer in the Sustainable Bus, we start to launch our next central motor platform in the next months. We'll be on the APTA show in Orlando. We start with a version for 18-ton vehicles, so it means a 12-meter bus. We followed in the next year with its bigger brother for the articulated bus on up to 32 tons. Main target is cost reduction, to increase power and torque density. That means, by the way, lower weight by similar performance, further efficiency increase, and improved scalability. We also work, as already mentioned by Mart, on electric axles. So we started a development project for a low-floor electric axle for low-floor city buses. But we also work on concept studies for long-haul trucks. On the inverter side, we already introduced in 2020 our third generation of alpha inverters, which are now used in new projects by our customers, and we will launch further variants next summer as well. Targets here are also further increase of power density and reduced costs. So energy efficiency, in our opinion, for commercial vehicles with 1 million kilometer and 70,000 operating hours is the most important factor for the propulsion system. Thank you.
Thank you to you, Eugen. So a lot of stuff going on, and we look forward to see the next generation Siemens eDrives being released in the coming months. Now, from the technical area, I would like to switch with the Caetano bus, with Paolo, on a financial topic. I guess it was Lionel Boileau before mentioned as a kind of a way to finance fuel cell buses, the leasing option. And Caetano Bus announced recently a strategic partnership with Toyota, but also involving the rental company Finlog, with the goal of providing an operational lease on buses in Europe. So Paolo, let me ask you if you want to be kind of more specific on this tool. Thank you.
So we already start since some years ago in the electrical strategic, where we not only sell a vehicle, we supply complete solutions, a complete solution that it comes from a finance point of view of the vehicle itself, the batteries, the charging infrastructures. So this is the point where for hydrogen, we will think in a way of how we can proceed with these mobility solutions, not only the vehicles to sell, but a complete solution for the hydrogen vehicles. So this alliance with Toyota is a big step to us. Right now, we are delivering Toyota brand vehicles. Caetano Bus belongs to Toyota structure. And of course, that Toyota Finance is supporting us on these activities. Nevertheless, in Portugal, even with Finlog, that was a Salvador Caetano company that already belongs to Toyota company. We all together, we are developing a business case where we supply to the operators, and a solution, a finance solution for a complete pack of the rental operation, or a fee for the operation itself. This means that we will work on the product itself and the finance schemes, and maybe in the stations. Let's see what future will reserve to us, but this is our strategy for the future. Nevertheless, even from the vehicles point of view, we are a budget and coach company, and with the apron vehicles that are the Cobus vehicles for airports. So we see that in the future, our cities, from the buses, activities, coaches, and in the airports, will have our vehicles that will be in hydrogen.
Thank you once again. So now let's conclude our roundtable and involve once again Alexander Schaber from VeriCity. From Alexander, we saw from your background the logo of ChargePoint, and we know that last summer ChargePoint took over VeriCity. Now we are very curious about how and if this takeover affect or will affect the structure and activities of VeriCity. Can you tell us something more?
Yeah, absolutely. Yeah, as you can already see in the background, I've now got the ChargePoint logo behind me, not anymore the VeriCity logo. Let me perhaps start why we as VeriCity decided to go this path and get acquired by ChargePoint. We have seen and we had a lot of talks with ChargePoint, and we still see that there's a great fit between the teams. We both share a joint vision towards zero emission mobility. We have a similar company culture, and in both companies, we have a really highly motivated team, and the products and the market focus is very much aligned. So that led us to the conclusion that the best way forward is to go together into this market. And the acquisition has strengthened us on a lot of levels. Next to the financial level and a lot of supporting resources, looking at HR, looking at finance and other topics, we also see that we have great overlaps in the fleet business. And ChargePoint wants to strengthen and expand the fleet business, and that's why we were also a perfect candidate to work together with them. We have now the full support to grow the company and to continue to have the best-in-class products and after-sales service. And ChargePoint is perhaps known more as a charging station, so as a hardware company. But in the fleet business and also in more and more other areas, what is important to understand is that ChargePoint is a software-first, hardware-second company. So it is about being agnostic, being open in the market. And with this mission and vision, we're going to continue to focus on staying agnostic, working with any vehicle and charging station provider. On the vehicle side, also with any drivetrain provider. So we don't care if it's a battery electric bus, if it's a hydrogen bus, if it's a hybrid bus, or perhaps a diesel bus. We focus to work closely with our partners and to provide the best value for our vehicle operators. So at the end, our joint end customers. And they're really making sure that we can provide them the best product and help them with a transition towards zero emission mobility.
Thank you, Alex. Thank you to all of our speakers. It was a pleasure listening to you. Very, very interesting things, very interesting concepts were said today, and we are very happy. We really hope our audience had the same feeling we had here. Now, we'd like to leave the microphone to Efe Usanmaz, WTP, for takeaways and conclusions of this webinar. So please, Efe.
Thank you very much. I put together some slides that might support very quickly. So sharing my screen. So actually, it's very hard when you have high level inputs and very good insights to summarize as well. But main takeaways, we see that zero emission buses are there in the will be there in the coming years.
We cannot see the slides.
Oh.
We couldn't see the slides before. Try again.
Maybe now?
Here we go. Thank you.
Yeah. So the key takeaways from my point of view is that zero emission buses are essential in the coming years to achieve our climate targets. So we have the relevant policy framework for it, and European cities and bus operators are apparently committed to reduce emissions, therefore applying the fuel cell bus solution as well. We've listened operators and industries, so we have a shared key aspects to consider when deploying zero emission buses, especially fuel cell buses. So we need to think from the system point of view, like we should focus, as David was saying, not only on vehicles and HRSs, but also we should cover maintenance aspects as well. So for this, we need to see the depot adaptations, including safety regulations, deployment, staff trainings, and so on. And like Bolzano, we also come up with innovative approaches like HRSs in the bus depots, also to accommodate growing fleets. thinking big is important in fuel cell sector. Also to my experience. So we have cities like Dijon, for example, putting together a fuel cell strategy, an ambition to full conversion of 200 vehicles, as we heard from Thomas, into fuel cell hydrogen. And we also know that different hydrogen production methods and resources are key. Therefore, yeah, the local context and operational conditions is important to decide which way to go. Fuel cell technology will be there to take the challenge. So as Lionel was saying, it's not, we are talking about, not about the prototypes anymore, but the technology is progressing very well. We've achieved key main KPIs by JIVE projects, and it attests that the technology is mature now. And early JIVE performance results show that we have 7 to 10 kilograms hydrogen per 100 kilometers on bus side. And we have, for example, 95% availability on HRSs. We heard from Transdev colleague, upcoming application could be on intercity routes, and buses and coaches are different when it comes to the fueling regime. So this is something to take into account. And we know that industry is ready to match the demand as cities are increasing their commitment to the zero emission technologies. So we do have some challenges ahead when it comes to all technologies, but specifically on fuel cell, we heard that standardization of HRSs and permitting are key for future uptake. We heard from VDV that the lack of refueling infrastructure is somehow challenging in Germany, so we should focus also on this. Energy mix and state of the grid, key to decide the carbon footprint of hydrogen, green hydrogen or byproduct is somehow very relevant. TCO is as mentioned by colleagues, is important, meaning that the price range of hydrogen should go down around €5 per kilo to achieve this cost parity with battery electric buses. And we heard that in 4 or 5 years, it could be doable. We also know that fuel cell has still a battery on the bus, so it requires close monitoring and maintenance as well. And IT software, the data loggers and so on are key for efficient operation and maintenance and to get the data right. So to conclude, I mean, even now we've been discussing since 2 hours and we have a great knowledge about the fuel cell buses, thanks to all panelists as well. And it's key to continue this exchange. And we have, as I said, Clean Bus Europe platform to do so, and JIVE projects. So we invite you to follow the projects as well and continue sharing. And of course, as mentioned, it will be an interesting 5 years ahead to consolidate fuel cell bus in European market. And to this, we need more and more funding models as well as cooperation among stakeholders like we have today. So I hope this gave a clear or somehow understanding of today's discussion. As I said, for me, even it was very, very informative. So thanks to you all.
Thank you very much. If a very challenging duties you had opening and closing the webinar. So once more, many thanks. I also take away all of things from the webinar. You mentioned 4 or 5 years to reach parity with battery electric buses. This is a figure we keep in my mind as TCO is absolutely crucial. And I mean, we are on the way to a commercial application of fuel cell buses. So slides and video will be available in very shortly, maybe already tomorrow. We got some requests on email, so I will be saying that maybe tomorrow or at latest on Monday they will be available, and all people who signed up will receive an email with all the information, the links and so on. So, and to conclude, we are over the 2 hours, so very much for our webinar. I guess this was our second and last webinar for Sustainable Bus 2021. I will say it very honestly, it was kind of a pilot edition. We had very good feedback, so be tuned for next year, as we are already working on a more extensive program for next here. So thanks you to all the attendees who have been with us all these couple hours. Thanks to the panelists, and a particular thanks to also Transdev and Keolis Group as our mobility partners this year. Thanks, of course, to all our sponsors. I wish you a nice evening and think big, like bringing back another of the message of today's webinar.
Goodbye.